Okay, thanks, Dave. Thanks, Brian. So I'm gonna talk about Neon. I'm gonna talk a little bit past sort of data networks and how we're building Neon, and then a future look. But I'm gonna start with a joke, and I think this is a joke that most, if not all of you, can sort of relate to here. So this is about traditional science. So this is what the scientists needed. It was a swing, and this is how the scientist went and described it to another scientist. And then this is what the engineer thought that the scientist described. I've felt like that before myself. This is what the proposal promised. I love the light. This is what the reviewer understood. I really don't get that. But this is what the funding agency was hoping for, and this is so true. I love the fruit on the trees. This is what university management was hoping for, and this is how university management supported it. That's so true. And this is how the project was documented. That's all too true. This is when it was finally delivered, and then this is what the scientists really wanted in the first place. So the point here is that if we're going to build a giant data network, we need to sort of think beyond traditional science, even though this is more of a joke than anything serious. So what I want to talk about, I'm going to talk about quickly sort of a history of past data networks, and then talk about how we're doing at Neon, building the Neon network, and then sort of think about the future and how we as representatives of different data networks can get together on this. Okay, so as far as I can tell, all networks, data networks, observatory networks, whatever, fall into one of these two categories. This is I think. So there's the bottoms-up network and the top-down network, for lack of better names. Bottoms-up, that's the PI-led, grassroots. Everyone has their own funding, their own science questions. They've got their own measurements they're making, and then eventually they realize there are other people making these similar sorts of observations. We have similar data sets. Let's get together and try to collaborate. And it's a great opportunity for discovery. You can do some neat experiments, make big, cool scientific contributions. Very non-standardized. Everyone measures in their own way. And usually the statement is something like, I measure this way because I know what's best for measuring in this ecosystem. Hear that a lot. The top-down approach is very rigid. That's where someone comes in and says, look, I'm going to build a network, and we're going to do everything the same way everywhere, using the same instruments, making the same observations. You typically don't have a whole bunch of PIs. You have sort of one PI and a bunch of staff scientists or something similar. You can engage very well with PIs because you're collecting lots of great data, but you're very limited in your flexibility, so it's very, very standardized. I'm going to talk about examples of sort of these two different networks. Neon very much falls on this right kind of top-down category, and I'll sort of explain as we go through. Okay, so the oldest reference that I could find to a quote-unquote modern network is the 1650s in Italy. The De Medicis, they funded the first weather-observing network. And you can see the list of cities here, number in Italy, as well as Austria, France, Poland. And they collected all their data and they sent it back to Florence. I guess that was like the data archive center that they had back then, and that's where they processed the data. And so it's not a whole lot different from how you think of some modern networks, right? Distributed, making the same measurements, sending them to a central location. And I've got this map just showing that a couple hundred years later, they were actually sort of getting global pictures of what's going on. So things progress pretty quickly. And in fact, the whole meteorological community is really, in my mind, been an example for how to build a real successful network. And if we look now at, say, the WMO network around the world, this is a fuzzy picture of their regional basic synoptic network. It's more than 4,000 sites. All those red dots are sites. And it's very standardized, right down to the precision that your measurements should be, how their sensors are calibrated, down to 3 decimal places. It's very, very standardized. And everyone shares their data. There's no question. Metadata is going to be shared. You turn on the TV, there's a guy on there on the news telling you the weather. They're not holding back any weather data ever. It's a very open kind of community. Everyone is sharing things. This is an example of a kind of top-down style. A successful one, too, I'd say. Okay, on the other end of the spectrum, I used to work with this network. It's a great network. It's called the EndF Network for the Detection of Atmospheric Composition Change. All kinds of great measurements, in-situ and remote sensing all over the world. These are their different sites. It is very much a PI-led network. Everyone gets their own funding, buys their own stuff, makes their own measurements, has their own science they're trying to do, and then they try to get together and collaborate in a coordinated way. In fact, I was on a committee maybe 10 years ago for EndF about data format, and that's when I learned how much people like ASCII. ASCII was everyone's favorite format. It's tough for me to swallow. So this was like a PI-led grassroots ground-up network, also very successful. Okay, kind of in the middle is another great example. This is NADP, the National Atmospheric Deposition Program. These are also individual PI-led sites, and essentially they're collecting precip that they then send in for chemical analysis. And so although it's independently funded, it's very bottoms up in terms of funding and establishing the sites, the analysis is very standardized. In fact, I think you have to collect your rain sample every Tuesday at 10 a.m. Like there's a standard of exactly when you collect the sample. Like it's sent to a central analytical lab in Illinois where it gets processed and is highly calibrated. And you're able to create these beautiful maps like this. So there's sort of room for in between is the message I'm trying to make here. Okay, so NEON. So we're from the National Ecological Observatory Network. NEON was funded very much in this top-down standardized approach to making a data network. These are the 7 grand challenge areas for NEON, so drivers and sort of responders to change. And so we are going to make hundreds and thousands of measurements that are related to these different areas. And I'll show you the map quickly. So Mark made reference in his talk to the NEON domains. This is a map of the 20 different NEON eco-climatic domains, including all the lower 48 states, Alaska, Hawaii, and Puerto Rico. If you look at the boundaries, you can maybe argue a little bit about whether there should be this little groove or this little kink here, but it's actually a pretty good map. If you get like the soils map, for example, it lines up quite well with these different domains. In each domain, there's a big red pentagon, and that's the core site that'll be there for 30 years, sort of making natural land use measurements. And then there's also 2 triangular sites. Those are the relocatable sites. They'll move around every 10 years or so to look at different cool science gradients and questions specific to that domain. There's also aquatic sites. Those are the blue circles and squares that are located in the different domains. And they'll be making measurements specific to the aquatic environment. And we've got an airborne platform. There's remote sensing over the sites. And so it's a very extensive kind of ambitious network and like I say, very standardized. So just to give you an update on how we're doing, we were funded to start building this in early 2012, late 2011. And so far we have data coming in from these 8 sites. And if you go to our data portal, you could download it. It's very preliminary, of course. It's still sort of a work in progress. But we're also constructing another 23 sites right now across the continent. So in various stages of construction. Might be running power, it might be building a tower, it might be deploying sensors. But so far, we're more than halfway through getting things going here for the network. Hoping to get this all built up by about the end of 2017. And so we're going to make measurements in all different areas. This is my attempt at summarizing 500 data products in one slide of photos here. So there's people making what I call traditional organismal ecology measurements, collecting bugs and leaf litter samples and so on. There's people doing aquatic environment measurements. There's all the sensor-based measurements that are made on the tower and in an array of instruments on the ground near the tower. There's a museum and collections archiving service, so samples that are collected out in the field are then maintained so they can be released to the community on request. And then there's this remote sensing payload that are flown on our aircraft. So many different moving parts, many different facets, lots of data. And the challenge for standardizing something like that is getting it to work in every ecosystem across the country. So I've got pictures here from Alaska down to the southeast, the northwest. Was just in Hawaii last week. Every single place like this has its own unique challenges as to how you want to do a standardized measurement. And the most frequent question I get when I give a talk is, have you thought about measuring this at our site? And the answer is yes, I have, but we're standardized. And so we can't really do that. We lose all that flexibility, that cool PI, exploratory discovery flexibility. That's kind of lost with this very standardized network. The answer, the most political answer would be, yes, that's a great idea. We should work on a grant together so you can come in and make that measurement yourself. But that sort of defeats the purpose of the network. So very standardized across the board. And the idea, the motivation for being so standardized is that if we keep all the measurements in the same format, the same calibration, the same collection frequency, we can synthesize them all together to address these great societal benefit areas and address those grand challenge areas in climate science. And so that's the reason that we want it to be so standardized, so things are so fluid into this process. So I wanted to quickly sort of compare a handful of networks and sort of different approaches that are being done. So just for the sake of argument, I grabbed these 4 different networks. They're all funded by NSF, and they're all in the US here. So there's NEON, there's the Ocean Observatories Initiative. That's got kind of like 4 or 5 main nodes to their network, and they do all kinds of ocean work, as you can imagine. LTER, you can tell by their logo, they've been around a long time, right? They're like the grandfather of network research. They've got over 50 sites, I want to say, around the US. Very much that traditional kind of PI-led bottoms-up grassroots style of science. They do some great work. In the last 10 years, they've actually put a lot of effort into becoming more coordinated as a network. They've got a big network office down in Albuquerque, and they work hard to try to collaborate together. And then there's a new network, CZO, the Critical Zone Observatories, also funded out of NSF. And I think they have maybe 10 sites now. They're just sort of getting up and running. And they've just opened up, I think, their national coordination office. And so also, the point I want to make here is also these sites that are grassroots and PI-led are also starting to coordinate in a more standardized way. So standardization is sort of becoming a theme even in the non-standardized networks. And I would argue that's very important because we're in this world of data now. We've got to share our data. Data's everywhere. That's where the emphasis is. Like those old meteorological networks that people never thought twice about sharing data, that's kind of where we need to get to because it's sort of the future. And ideally, we'll end up in a situation like this. Brian gave me this slide. Thanks, Brian. This shows how all the different measurements that we make in our different data networks in the ideal world will come together in a uniform cyber infrastructure where everything's nice and standardized, and then they're able to go up to these different agency groups, different networks, different academic areas, and policymakers and decision makers will be able to really interpret these in a meaningful way. That's where we want to get to. And so I think the standardization is a good step in that direction. It's certainly not necessary. It has its cons associated with it, but it will help us get toward this more free-flowing network integrated view. And I've got at the bottom there the garbage in, garbage out. Even standardized garbage is garbage, right? So it's data quality still can't be missed here at any stage. Okay, that's it. Thank you.
Thank you, Jeff. We do have time for some questions, so I'll draw your attention to the microphone in the middle of the room. Why don't you go ahead and use that? Yep, sir.
I just want to call attention to the Department of Energy small network, actually called ARM, Atmospheric Radiation Measurement System. And ARM has it started out with 3. They had proposed 10 sites. They found out that they couldn't afford 10 sites. They cut the list to 5, and now there are 2 surviving sites. But these sites are somewhat intermediate between the strongly top-down run network and the PI sites. They're defined as user facilities. So there is a standard set of measurements made at all sites, and that's very highly regulated. But the sites are available to users from anywhere in the world on a very short proposal basis. So users can come in and bring their own instrumentation, and of course they have access to all of the standard data as well. So I don't know if NEON proposes something like that or not.
We really hope we can get there. It's a few years down the road for us, but ARM has been a great example for us. In fact, a lot of our automated quality control processes that we're looking at, ARM is leading the way in that area, so a great network.
And we have time for another quick question as well. Anyone? Yes, sir.
come from the ecological community in Europe, and there we see also the discussion and the waves towards standardization, and I see the reason why that is important. But I also see big drawbacks, because there also is a tendency that only things that can be standardized, only measurements that can be standardized are being seen as being important. And for example, in the LTR sites, there'll be lots of measurements that are not easy to standardize, which doesn't mean that the knowledge that comes out of those measurements may not be unimportant just because they cannot be standardized. So I think there's a risk that if we focus too much on standardization, there'll be important information we never get.
Yeah, I absolutely agree, and I would add to that you know, being standardized at a network costs a lot of money, and so you're probably only going to have a program officer or a funding agency invest in building a network that has very mature kind of science where it's relatively understood. Cutting edge stuff doesn't fit into that model very well. And this is where the non-standardized sort of more traditional PI-led science can do some great discoveries, great cutting edge research, where the standardized data network will be limited in that capacity. So I totally agree with your point.